Hello and welcome to the NROL-77 launch webcast. SpaceX's Falcon 9 rocket is currently awaiting liftoff from Space Launch Complex 40 at Cape Canaveral Space Force Station. My name is Amanda Yers, and I'm a ground systems engineer here at SpaceX. Today's mission carries a national security payload designed, built, and operated by the National Reconnaissance Office, or NRO. NROL-77 will be SpaceX's 11th national security space launch this year. The range is currently green, and we are on track for an on-time liftoff at 2:16 p.m. Eastern Time. If for any reason we are unable to launch today, a backup opportunity is available tomorrow at 2:02 p.m. Eastern Time. But for now, the weather is looking good with just a 2% possibility of launch weather constraints. We will not be showing any Stage 2 or deployment views today at the request of our customer.
This is LD on countdown 1, performing hold authority comm checks. NOPS OD.
With that, let's meet our Falcon 9 rocket on the pad.
STC.
Loud and clear.
TC.
Loud and clear.
PD.
Loud and clear.
Comm checks complete.
At 229 feet tall, our two-stage workhorse produces more than 1.7 million pounds of thrust. And rockets like Falcon 9 don't use all that power to go straight up. Early in flight, Falcon 9 performs a gravity turn, which is a smooth pitch maneuver that tilts to build up horizontal velocity. You may hear this called out about 10 seconds into launch as the vehicle pitching downrange. Once the first stage completes its portion of the mission, it shuts down and separates. A staged rocket like Falcon 9 sheds the booster so Stage 2 and the payload can continue to climb faster and more efficiently. After stage separation, today's booster will land back at Cape Canaveral Space Force Station's Landing Zone 2. This particular booster will be returning to Earth for its fourth time.
Engine chill has started.
It previously supported KF-1, IMAP, and one Starlink mission. The second stage will take over from there, powered by a single Merlin vacuum engine, also known as the MVAC for short. With its extended nozzle and optimized design, the MVAC drives maximum performance in the vacuum of space. Topping it all off is the payload fairing, a 17-foot wide carbon composite shell that protects the payload during the uphill trip through the atmosphere. About 3 minutes
Stage
into
1
flight,
RP1 load is complete.
the fairing halves will separate and parachute back to Earth. Our fairing halves today are new, and they are each flying for their first time. If recovery goes to plan, they will be pulled from the ocean and prepped to fly again. So much of what makes Falcon 9 remarkable happens in flight. The stages separating, the first stage landing itself back on land or on a drone ship in the middle of the ocean, fairings parachuting back, all to get ready for another planetary future. Now back to today's mission. Weather continues to look favorable for launch with just a 2% possibility of launch weather constraints. Coming up next in the countdown, the Transporter Erector, or TE, will begin to retract away from Falcon 9. That's the large truss structure that you see standing next to the rocket. It's hinged at the base and connected to a launch mount beneath the first stage. In the retraction process, first the clamp arms around the second stage will open. Then, once the clamp arms are clear, the TE will begin to pivot backwards, slowly swinging away from the rocket. There's a great view of those clamp arms
for strong back retract
around the second stage, and we just heard that tanks are pressing for strong back retract, which is a great sign that we're right on track. You may also hear our team refer to the TE as the strong back, which is the same structure, just a different name. The TE rolls Falcon 9 out to the vertical, and it stays connected through the final seconds of launch. It provides fuel, power, telemetry, and command connections between the ground systems and the rocket.
Strong back retract has started.
Strong back retract process is now underway, so keep a close eye on those clamp arms as the strong back clears the vehicle and eventually pivots backwards from Falcon 9. These clamp arms help to stabilize the second stage during fueling, and they also prevent movement in high winds. Once they are open, fully free at the top. Right now, both stages are nearly fully loaded with about 1 million pounds of propellant, and that includes RP1, highly refined kerosene, as well as liquid oxygen chilled to over 300 degrees below zero. Propellant is loaded late into the countdown, and that's intentional. Colder propellants are denser, and denser propellants mean achieving more performance out of the same tanks. Before any of that propellant flows, the plumbing and engines are chilled down. That priming process prevents thermal shock and boil-off when that ultra-cold liquid propellant starts moving at a high flow rate. You'll hear this priming process referred to as engine chill. And there you can see the strongback is beginning to retract away from Falcon 9 with the clamp arms fully open and clear of the second stage. The propellant loading process will wrap up in 2 steps.
Stage 1 LOX load is complete.
The first stage just finished the liquid oxygen loading, and second stage will wrap up about 1 minute from now. In addition to RP1 and liquid oxygen, cryogenic helium is loaded onto Falcon 9. Falcon 9's tanks are pressurized using that helium, and the helium must be chilled to remain compatible with the remaining cryogenic plumbing. During flight, the pressurization force from the helium helps to force propellant into the engines as the tanks empty. As we await the completion of Stage 2 liquid oxygen loading, minus 60-second mark, Falcon 9 will enter startup. At that point, the rocket's onboard flight computers will take over, and from there on out, the countdown is fully autonomous. Just inside of T-minus 2 seconds, the 9 Merlin 1D engines will ignite. Once they're at full
Stage
power,
2 LOX load is complete.
Falcon 9 will lift off the pad and begin its climb to orbit, and we just heard confirmation that liquid oxygen loading for the second stage is complete, which completes the propellant equation for Stage 2. At this point, you've probably noticed the white clouds venting from the rocket. That comes from the super cold oxygen gas on board. When oxygen is vented overboard and interacts with the warmer outside air, it condenses into clouds. It's the same principle as seeing your breath on a cold morning, just on a much larger scale. Weather continues to be green,
Ground gas closeouts.
tracking a 2% possibility of launch weather constraints for our scheduled liftoff at 2:16 p.m. Eastern Time. The gas closeout process is underway, which refers to venting and shutting down gaseous systems such as topping off the tanks and sealing vents to maintain pressure. Now we're standing by for confirmation that Falcon 9 will enter startup at the T-minus 1 minute mark.
Falcon 9 is in startup.
At this point, the autonomous flight computers have taken over the launch countdown, and stages 1 and 2 are pressing for launch. Let's listen in to the launch director's final go.
MD is go for launch.
As you heard, we are go for launch. Let's listen in to the final seconds of the countdown.
T-minus 30 seconds. T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engines full power and liftoff. Go Falcon, go NROL-77.
Vehicle is pitching downrange.
And with each chamber pressure is nominal.
At T plus 30 seconds and counting, Falcon 9 has successfully lifted off from Space Launch Complex 40 at Cape Canaveral Space Force Station. And in just a few seconds, we'll throttle the engines down in preparation for Max Q, which stands for Maximum Dynamic Pressure. It's the moment in the
Power
launch
and telemetry nominal.
when the vehicle experiences the greatest mechanical stress that it will see during its ascent. To help go from vertical to horizontal, the first stage also performed a gravity turn where the engine's gimbal a
Falcon
small
9 is
amount
supersonic.
to turn the first stage from going straight up to horizontal with the help of gravity. Eventually, Falcon 9 will be roughly horizontal to Earth as we achieve orbit.
Max Q.
Falcon 9 has just passed through max Q, and the rocket typically needs to go 17,500 miles per hour horizontally in order to avoid being pulled back down to Earth and get into orbit. You can track our progress to orbit by watching the left corner of your display, which is showing first stage velocity and altitude. We have several events coming up in quick succession, and we should hear them all called out by mission control. These include main engine cutoff, or MECO, stage separation, stage 1 flip, second engine start 1, and boost back burn. Main engine cutoff is when we shut down all 9 M1D engines on the first stage. Stage separation is when the first and second stages of Falcon separate from one another. Stage 1 flip is when the booster uses its nitrogen gas thrusters to flip the booster around. Next, second engine start 1, we will light the MVAC engine on stage 2 for the first time, and after that is boost back burn, when the engines will light to place stage 1 on a trajectory towards the landing zone. So keep an eye out for these events happening back to back.
Stage separation confirmed.
Stage 1 boost back startup.
And there we had conclusion of that quick series of events, which again were main engine cutoff, second stage separation, stage 1 flip, second engine start 1, the MVAC engine, and the start of the boost back burn. Coming up next will be fairing separation in just a few seconds. The fairing will jettison away from the second stage as it is no longer required to protect the payload once we're in space.
Fairing separation confirmed.
And there's that confirmation of fairing separation. As we mentioned earlier, we will be attempting to retrieve these fairing halves once they fall back to Earth.
Stage 1 boost back shutdown.
Stage 1 has concluded its first of 3 burns on its way back to Earth with the confirmation of boost back shutdown. This has properly oriented Falcon 9 for its return trajectory. And we're currently just past 3 minutes and 40 seconds into today's mission. The next major milestone is coming up at the T+ 6 minute and 44 second mark, when you should see the first stage's entry burn on your screen. To start the entry burn, we will relight 3 of the 9 M1D engines on the first stage, starting with the center engine, known as E9, followed by E1 and E5. The booster engine graphic on the right-hand corner of your screen displays...
Both vehicles are following nominal trajectories.
Great confirmation, both vehicles on nominal trajectory. The booster engine graphic there on the right-hand corner displays the arrangement of the 9 M1D engines, with an outer ring of 8 and a center 9th engine. These are held in place on the vehicle by a structure called the octaweb. And again, 3 of these will light during the upcoming entry burn. The entry burn is similar to pumping the brakes to slow the vehicle down as it passes back into Earth's atmosphere. And we need to slow down to reduce re-entry forces. This helps us to recover and ultimately reuse the first stage. During the entry burn, Falcon 9 is decelerating by firing its Merlin engines, but the vehicle is still moving really fast. This causes it to fly through Merlin's exhaust gases, also known as the rocket's plume, which deposits a layer of soot on the vehicle's surface. That soot comes from the carbon-based fuel, RP1, that Falcon 9 uses. With each flight, that layer of soot builds up a little bit more on the surface of the vehicle, and that's why our flight-proven vehicles look the way they do. Now we are still just over a minute away from the beginning of the entry burn. You can see on the left-hand corner of the screen the first stage is decelerating as it makes its way back to Earth. The first stage is not only going to use the Merlin engines for re-entry and landing, it will also use the titanium grid fins and nitrogen gas thrusters for stability and control. Falcon 9 is attempting a re-landing today back on land at Cape Canaveral Space Force Station's Landing Zone 2. As a reminder, at the request of our customer, we will not be displaying any views of Stage 2 for today. Falcon 9's reusability is key to lowering the cost of spaceflight, enabling more investments in critical space infrastructure. It allows SpaceX to refly the most expensive parts of the launch vehicle, which in turn drives down the cost of going to space, making missions like today's possible for more organizations and more often. The Falcon 9 first stage supporting today's mission will be performing this upcoming entry burn for its 4th time. Now we're about 10 seconds away from the beginning of entry burn, and again we'll be relighting 3 of the 9 M1D engines.
Stage 1, entry burn startup.
There's that call out for the startup of the entry burn on Falcon 9's first stage. This is set to last about 15 seconds. And again, we're slowing the vehicle down in preparation for its final burn and landing.
Stage 1, entry burn shutdown.
The entry burn has shut down on the Falcon 9 first stage. Coming up next will be the first stage landing burn about 1 minute from now. The Merlins on Falcon's first stage are optimized for sea level, and these each achieve 190,000 pounds of thrust during ascent and descent. They provide the initial power to lift Falcon 9 out of the lower, thicker part of Earth's atmosphere. In comparison, the single MVAC engine on the second stage has a much wider nozzle, and it's optimized
Stage
to
2 is in
perform
terminal guidance.
in space, producing about 220,500
Stage 1
pounds of
FTS
thrust
has safed.
in a vacuum condition.
Stage 1, transonic.
In about 10 seconds, we'll have the start of the landing burn for the first stage. This is the final burn of the Falcon 9 booster, used to reduce the remaining speed of the vehicle for a gentle and precise landing. We should be hearing that call out shortly.
Stage 2 FTS has safed.
Stage 1, landing burn.
The landing burn has started up on Falcon 9's first stage. This is the final burn the booster will see prior to landing.
Stage 1, landing leg deploy.
Nominal orbit insertion.
Stage 1, landing confirmed.
And there we have another successful landing of our Falcon 9 rocket. This was the 4th launch and landing for this first stage. As a reminder, we will not be showing any Stage 2 or deployment views at the request of our customer. So with that landing of the Falcon 9 booster, we'll be bringing our webcast to a close. We'd like to thank the Space Systems Command and National Reconnaissance Office for entrusting us with today's mission, and we would also like to thank the Range and FAA for their support. If you're interested in more launch coverage, head over to spacex.com/launches for the most up-to-date information. When you're there, check out our departure board with all the details of our upcoming missions. Remember to follow @SpaceX on X for more updates. Thank you for tuning in, and we'll see you next time.